Dear friends and colleagues, welcome back to the Mangano Digital Academy and welcome back to the Essential of Digital Dentistry. In this short video, we will talk about the acquisition software of the Combin computed tomography and how valuable it is as a tool for planning, for example, for planning the implant position. Digital dentistry, as I told you in the previous lecture, is fundamentally based on 4 different steps. The first step is the data acquisition, and we have talked in full details about data acquisition with the Combin computed tomography and with intraoral scanners. Now, in this second part of 10 videos of the Essential of Digital Dentistry, in the second part of this project, we will talk about the software, we will talk about the data elaboration, we will talk about the second phase, the plan phase. After this phase, of course, we have the make, we produce something, and then we have the clinical application. So let's go through the planning, that it's essential, of course, in digital dentistry. Let's go to the softwares, and let's go in particular to talk about the software of the Combin computed tomography. That is a very valuable visualization tool and also very valuable for planning, of course. So, implant planning with Combin computed tomography acquisition software. How to do it? How to correctly do it? It's very important to use this software well in order to gather a lot of information that are very useful also later when we plan inside the computer guided surgery software, for example. Let's talk about the Combin computed tomography. As we know, in the late 90s, a new technology, the Combin computed tomography has come, and it was a revolution. It is still a revolution because we have the possibility to acquire data from our patient in 3D, and it's very important. This technology uses a cone-shaped beam and a reciprocating detector which rotates around the patient 360 degrees and acquires projected data in a single rotation. The Combin computed tomography since the late 90s, invaded dentistry, making the perception of 3D easily acceptable to dentists. It's not surprisingly, this technology has been adopted by many digital dentists all around the world because it changed completely the way we can make diagnosis and also in the way in which we can make our treatment plan. Let's see one case, for example, of implant planning with using the Combin computed tomography acquisition software. This is a male patient, 74 years, and we have to plan 3 fixtures in the posterior mandible, and one of the sites is a post-extraction site. And we have the Carestream CS9300 in this case, with the Combin, and the field of view selected is 10x5, that is very useful for this kind of planning, and we plan our implant position with the Carestream CBCT acquisition software. The first things that I do when I enter in this software is setting the brightness, the contrast, and preparing the filter for seeing better in our multiplanar reconstruction. Is the first things to do. I think you can do it 2D in the different multiplanar reconstruction using that tool, and then after you have set the best brightness and the best contrast, you have selected the best filter for your case, then you can also prepare and set the 3D rendering, because it's also important to have this immediate visualization in 3D of the case, in this case the mandible, using these filters. After you have performed all the settings, you have adapted all the settings at best for your case, then you have the possibility to crop your project. You select a specific region of interest. Yes, because of course you have already selected a region of interest when you have decided, when you have chosen your field of view. In this case, a 10x5, because I want to see the whole mandible. But of course, there's the possibility to perfect the image and the region of interest, particularly using this tool, the crop project, in order, for example, to cut, in this case, the part of maxillary teeth that have been acquired anyway, in particular if they create, for example, noise and they disturb a little bit your 3D rendering and also your multiplanar reconstruction. So you can do it using this tool, for example, and you can simply, using this rectangle, select the region you want to to focus on, and it's possible and it's very easy. And after that, as you can see, you have eliminated all the scattering of the maxilla. In this case, you have selected only the area that you wanted to select, and in the 3D rendering immediately the area that were not interesting for you have been deleted, and this is very useful. Of course, there are also other tools in order to do that. You can have an improved 3D rendering visualization, and you can eliminate all the scattering. I told you there are also other tools inside the software. The software is very, direct and easy to use, and these other tools are here. For example, you can alternatively select and cut, crop the project using another region of interesting tool. These all before to start the planning itself. So these are the settings before to start the planning in order to perfect your image, the image you have acquired with the Beam computed tomography scanner. So this is another tool, and you can in 2D cut, moving these lines up and down. You can select exactly your region of interest and once again eliminate, in this case, the maxilla with the meta restoration and with the scattering. And more or less is the same. The result is the same because, as you can see, we can perfect our image, we can perfect our 3D rendering, we can prepare our case for the drawing of the panoramic curve. So after we have defined the best filters, after we have perfected the region of interest, now we can draw the panoramic curve. This is a key step when planning implant, for example, and now I will show you how to do it. The best way to do it is to try to draw this panoramic curve using that tool selected on the rectangle, on the orange rectangle, using this tool and trying to follow the path moving your mouse of the inferior alveolar nerve in the case of the mandible. Why? Because if you can do it, then you will have in the Panorex a clear, very clear image and representation of the path of the inferior alveolar nerve, and then it's very easy to draw the nerve itself exactly and directly on the Panorex using the proper tool, the tool for drawing the nerve. And it's very, easy, immediate and fast, and it's faster and it's easier exactly if you do it if you draw the panoramic curve in the best way, following the path of the nerves. Because after that, when you have the nerve draw very well in the Panorex, you will have also in all the cross section, the cross section, the possibility to see directly the inferior alveolar nerve, right side, left side. So it's very easy and very comfortable. So basically, if we follow the path of the inferior alveolar nerve when drawing the panoramic curve, we will perfectly visualize the nerve in the Panorex. We will have the possibility to draw very well and very easy and very fast the nerve using the proper tool in the Panorex, and then we will visualize exactly the nerve in each cross section. And it's exactly what we are doing here. As we can see, it's very easy, and then we have the perfect representation of the inferior alveolar nerve exactly in the cross section below. So there's a relationship between the Panorex and the cross section, of course, and we can choose also in this software if to see one cross section image or 3 or 5. There are several options you can use, but a very important thing is that the nerve will be correctly visualized in the cross-section images, and it's very helpful when you plan an implant, of course, or more implant like in this case, because you don't have to care anymore. Everything is very well and automatically visualized. And then it's very important to underline this concept. Then we go through the planning, and we need to move these little arrows, these blue arrows, mesial and distal, and we need to search our ideal position for the placement of for the planning of our first implant. And it's very important to have the perfect inclination of this line, this blue line, defined between these two arrows. Why? Because the implant position and the cross-section representation will depend mainly by this inclination, and this inclination should reflect the major implant axis. It's very important, because if I don't make this movement, if I don't move this blue line at best, representing the ideal position of the implant, the ideal inclination of the implant, then it will be difficult to perform to measure into the cross section correctly. So this blue line is very important. It is represented there, and in the cross section as well. And also in the 3D rendering, as you can see, you have this blue plane. We need to move and tilt it in order to be parallel to the main axis of the medial tooth, in this case, the 35, because I want to place the 46, and I want to place the 46 parallel, more or less, to the 45, considering also the inclination of the SPE. So it is very important to plan and to tilt this line perfectly in order to represent the ideal position of the implant. And then, after we have done it, we can make reliable and perform reliable measurement. Otherwise, our measurement will be not reliable. If this blue line is straight in the Panorex, it does not represent the real position we would like to plan with our implant and for our implant. So it's very important to have that plane, that blue plane, to have that blue line tilted correctly, representing the main axis of the future implant. Only in this case we can really perform reliable measurement, and also we can go through the pre-planning. I call it pre-planning because in real all my plans are made in a guided surgery software. But anyway, this visualization software of the Cone Beam Computed Tomography is very helpful in order to perform a pre-planning, to understand if there are the conditions anatomically to place the implant. It's like a pre-visualization, a pre-planning, a pre-screening of the situation. And it's very important, because if I have the condition, then I can move directly to the computer guided surgery software, and using this particularly this software, I can also import all the set of data, including the model taken with the intraoral scanner inside the SMOP software, for example, because there is a high compatibility between the Carestream visualization software and SMOP. But anyway, I can perform this measurement. They confirm that we can go on with planning our implant. So let's go on with the planning, and we can choose, for example, among the library, among different implants, brands, length and diameter, and we can, in order to pre-visualize how the implant will be planned and how the implant goes, and also the abutment. We have a series of information, and we can easily import this information. We can pre-visualize in the rendering how the implant goes. We can pre-visualize, the most important thing, the diameter and the length of the implant in the cross section, as you can see here. So implant planning is always in the cross section, and then we can control the position, the depth, the inclination, how the implant is tilted in all the multi-planar reconstruction, as well as the of course in the 3D rendering. It's very important. Here magnification of the 3D rendering, it's really important in this case, because it's a post-extraction site, so we wanted to insert the implant a little bit deeper inside the socket. And here also we can visualize from different sides. From the we have the possibility of a perspective view. We can change our setting inside the Cone Beam Computed Tomography acquisition software, and everything works very well. And again, other sections, as we can see, the relationship with the inferior alveolar nerve, the relationship with the remaining wall of the socket, and then we can go planning the other implant. As I told you, the very important thing is after we have completed the planning of 46, we go to the 35 and 36. The very important thing is always to tilt this blue line between these two arrows in order to represent what will be the real position of our implant. This blue line cannot be straight, because if it's straight, we don't have a reliable measuring tool in the cross section. Instead, we need to tilt this blue line in order to follow more or less the main axis of the mesial tooth, considering also the presence of the SPI curve, so and the Wilson, of course, curve, because it's important to remember the anatomy of the mandible. But anyway, we need to tilt it, otherwise our measurement will be not correct. And this is not trivial at all, because many colleagues don't consider it, and sometimes the measurement made in the cross-section are not correct because they are measuring in the wrong cross-sections, in cross-sections that really don't represent the real anatomy, the real situation useful for the planning. So as we can see here, the implant, once again, more or less parallel to the major axis of the mesial tooth. In this case, of course, if you don't have teeth, it's more difficult. But the planning is completed with the implant in position 35 and 36. Here with both the implants, the relationship with the nerve, we see that we have some kind of proximity in this case, but the nerve is very well visualized, and we have all the valuable information that we can collect. Also, we can make the bone transparent in the 3D rendering in order to better visualize the relationship between the implant and the inferior alveolar nerve. And the implant planning is completed. Also, we have an idea of the emergent profile, sort of pre-visualization. Of course, it's not complete like the one in a software like SMOP, but anyway, it's a sort of information that are very useful for our planning. And so we have the possibility to go on, how to go on freehand or guided, because at this point the planning is completed with this software, and it takes maybe 5-10 minutes. It's not difficult. So the surgeon can go on with a freehand implant surgery, because the surgeon has already collected all the valuable information for planning freehand. And it's possible to generate inside this Beam Computer Tomography Acquisition software a PDF file with the complete plan, useful for showing the planning and anatomic situation to the patient in order to have the plan approved by the patient, but also useful for the surgeon to remember all the situation before the surgery. Another option, obviously, is going guided. In this case, all this information are a sort of, pre-planning, and then we need to switch to a guided surgery software. In this case, the Carestream Dental Visualization software allows to upload the model from the intraoral scanning as well, the WOX-UP as well, and to switch to SMOP directly in order not to have to repeat some of this phase, for example, the STL model upload inside the SMOP. All this set of images, all this set of 3D data are imported automatically inside the SMOP software in order to proceed with the planning directly and for the design of the guide. And the implant planning is in this case very, very easy with the guided surgery software. We will talk about guided surgery software more in detail in the next lecture. In any case, when using the Carestream Dental Beam Computer Tomography Acquisition software, it is very important to think according to the correct session, as I told you, and to use the tools available, because these tools are very valuable. And in my opinion, there are two tricks. One is take a little bit more time to draw the panoramic curve, because if you can do it, as I told you, following a little bit the path of the inferior alveolar nerve, for example, in the case of the mandible, then you save a lot of time when you have to draw the inferior alveolar nerve. You can draw it directly in the Panorex, and it's a good advantage because you don't have to correct it too much, and you find it automatically drawn in each of the cross sections. So very important how to use the Panorex well. And once again, when you plan your implant, when you make your measurement pre-planning, it's very important to consider the axis of the mesial teeth, for example, and also the distal teeth. So implant planning should be done taking into account the main axis of the adjacent mesial tooth in particular where present. It is important to identify a plane parallel to the axis of the Panorex in order to have a correct representation of the anatomy in the cross-section images, where to make our measurement, and so where to plan our implant. Only in this way we will have accurate measurement, otherwise we don't have accurate measurement. So please take care of this step, it's very important. That blue line inside the software is very important. It must be tilted correctly in order to follow more or less the inclination of the mesial tooth considering also the speed curve and the Wilson curve. So that way we will not encounter any error. And we have our planning, and we can go through our PDF summary of the planning in details, and then the surgeon can search, can collect, can save several pictures taken from different multi-planar reconstruction, and this picture, all this set of pictures is included in this PDF in order to have the possibility to, finalize our case with the whole planning, with the whole position of the implants inside the PDF, the final PDF that is summarized. Once the gallery has been selected, we can prepare to the creation of the PDF that can be saved and also printed in a very elegant way, particularly if the dental clinic has a color printer available, in order to create a special, with the Film Composer, a special PDF collecting all the information of the patient, using also the logo of the clinic eventually, and this is very nice, a customized patient record. So it is possible using this software to design an elegant record with the most significant images of the planning to be printed and delivered to the patient, and this record can be attached to the patient medical record. So this record can also be customized by inserting the name and the logo of your own dental clinic. So thank you very much for your attention.